This video is we'll address our tangent lines. I was gonna look at some graphs and make sure that we're just not losing sight of what we're doing. Since we're diving into a lot of algebra, I mean calculus. We're learning our different rules throughout this section. I don't want us to lose sight of the fact that what all this stuff means. That slopes of the tangent lines can be a derivative at a point. So let's go. Sorry for the pun up there. I hate freaking puns. But we're gonna find an equation of the tangent line and normal line to the curve f of x is equal to x times the cube root of x at the point -8, 16. A tangent line, we know all about a tangent line. But normal line is something that pops up a lot in physics. Normal vector as well. But yeah, let's talk about it. Let's introduce it, because most of y'all are not here. You're not math majors. You need to do something with the math. So good on you. So I kind of drew it. I kind of drew a tangent line, and I kind of look. It's ish. I kind of drew what this looks like. X times x cubed, or x to the 4/3. And we drew a tangent line, right? We've got this little dash line, just being like, boom, 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 boom. That's your tangent line. Now, there's something called the normal line that is going to come out, and it actually just forms like a right angle. I don't know if that's right, but something like this. And yeah, I can tell that I did a horrible job at making a right angle, but there should be a right angle to your tangent line. We can say that this is the. See, I'm used to this being the normal vector. Don't write that. The normal line comes and makes a 90. So that means it's also going to go this way too. All right. So we're just trying to find the equation of that line. But it goes through the same point as the tangent line. So we're going to use the same point, -8, 16, when we create. We use point slope. Because once you have a point to create an equation of a line, all you need is that damn slope. But that's the tough part. But I don't think it's so tough anymore. I don't think that's so tough anymore. Sorry about that. Let's take our function and let's rewrite it. F of x is equal to x times x to the 1/3 power. I've already said it's 4/3. Because we're going to add those exponents together. 3/3 plus 1/3 is 4/3. That, my friends, is derivative ready. Let's go. So f prime of x is equal to, falls to the front, we get 4/3 times x to the 4/3 minus 1 is equal to 1/3. So we found its derivative. What we know is the slope of our tangent line. The slope of our tangent line at that point, -8, 16 is going to be equal to f prime of whatever our x value is going to be. That -8 is going to pop right into there. The whole point of using the notation with y'all, which means we should get this. Our x to the 1/3 power, and we pop in our -8. Ooh, let's go. Almost got that slope of the tangent line. Let's continue it down, and now we got that 4/3, but let's start thinking to the 1/3. I wonder if this thing's all cooked up, like -8 might be equal to something that's cubed. Like, is -8 like equal to -2 cubed? Is it? I think so. I hope so, or I made the problem wrong. I wanted to make it clean up super nice, because now we can use some exponent rules, right? We got these 4/3, and then we're like, whoa. So we got -2, and you have an exponent raised to an exponent outside of a parenthesis, like that. Not a tower. Don't confuse it with a tower. That's going to end up with that 3, that's that times that 1/3. That's when we do the multiplication of exponents, when you have a raised exponent to an exponent outside of a parenthesis, where they just cancel out and create a 1. So what do we have here? We got that -4 times -2 all over 3. Oh, let's get it. What's this thing going to be? Ooh, why did I write -4? Why did I put -4? It's not negative, is it? It's positive. So it's -8. Over 3 is going to be the slope of our tangent line. Tough part over. The rest is shit. The rest is cake. The rest is cake. So let's write it. Let's put it's y minus y1, that's that 16, is equal to the slope of our tangent line, that negative 8 over 3. Negative 8 over 3. And then we got x minus our x value, that negative 8, so minus negative 8. There's the slope of our tangent line. Look at that negative sloping thing going through that point. Negative 8 comma 16. So that means when we go to write the equation of our normal line, we'll do this in green, it's going to be y minus 16 is equal to and x plus 8. So all that's going to stay the same. It's just finding the slope of the normal line. So the slope of the normal line, that one that's going to be perpendicular, or maybe we can start thinking of the term orthogonal, kind of synonyms. Even your teacher doesn't really know the difference. You just kind of pretend like I do. Perpendicular and orthogonal, they form a right angle. Orthogonal seems to come through with vectors. We start getting all fancy with the shit we talk about. But whatever. For us, we could learn this back in, I don't know, algebra. Because we know how to deal with perpendicular lines. That's what we're going to take our slope of our tangent line. We're going to flip that thing over, and then we're going to hit it with a negative. So we're going to find out that it's going to be 3 over 8, but we're going to change it to a positive. So there's the equation of your normal line. That's all it is. Take your slope of your tangent line, flip it, hit it with a negative sign. You got yourself a solution. So that's for you science majors. You're gonna actually go use math, and I wanted to get those terms in for you. Really keep on me if you need the applied stuff, because I get hung up on the math. Man, you're gonna use this to be great one day, all right? With whatever you're going to do. So with this next question, we want to find the points on the curve y is equal to x to the fourth minus 4x squared plus 3, where the tangent line is horizontal. Cool. Tangent line, horizontal. Well, let's get the ruler out. Horizontal, zeros, right? But that's where we're going to find any sorts of peaks and valleys. So something like this. That's where the slope of the tangent line equals 0. Peaks and valleys. Come down here. It's kind of, I guess my graph's kind of, maybe there and there. We're going to go find first where this happens and where the slope of the tangent line, y prime equals 0, y prime equals 0, y prime equals 0. The slope of the tangent line equals 0 at these distinct points right here, and then of course you can see right here at x equals 0, we're going to find as a solution as well as to where. So we already know at 0, 3, that's where the slope of the tangent line is 0. Is that little tangent line? It's flat. Peaks and valleys, peaks and valleys, peaks and valleys. So that means the derivative is going to equal 0. And if the derivative is going to be equaling 0, that means we're solving for x, right? That's going to be the variables that are left. We're going to mess around with a bunch of freaking x's. We're going to solve for it. But the question asks for the points. So we're going to go get our x's. And then when we're done, we're going to plug them back in, go find our y so we can write them as points. Let's get it. The game is take a derivative, set that shit equal to 0. So we don't need to do any algebra to ours. It is already set up. We take our derivative, let's write it as y prime. We get 4x cubed minus 8x. Not so bad. Now here's the game. We took a derivative. We're super happy with ourselves. We need to take a derivative and set it equal to 0 and solve for that x. So we're going to change that y prime and we're going to say, let's set it equal to 0. But while we do that, let's do a little fancy factoring. So the reason why zeros don't, when you set it equal to 0, shit, that's how we can factor and solve. It's called the zero product principle. So let's yank out a 4x from both terms, leaving us with what? An x squared minus 2. Neat. Let's use that zero product principle that tells us if 4x equals 0, the whole thing equals 0. And if x squared minus 2 equals 0, the whole thing equals 0. Therefore, at x equals 0, the slope of the tangent line is equals 0. Holy shit! Who saw that coming, huh? And then here, I'm going to get weird. You can put it over on the other side. I'm going to write this as the difference of squares. X minus root 2, x plus root 2 is equal to 0. You can bring it over, but don't forget when you hit here with square roots, you got to be responsible. You got to be that responsible adult that remembers that plus or a minus, because that would suck if you miss it. So seeing the graph, it seems pretty obvious that we would have two answers, but maybe if you weren't making the graph. maybe you wouldn't see it. We all make silly mistakes. I try and tell you where I would make my silly mistakes as a student. So we found at x equals 0, we have the slope of the tangent line is equal to 0. And then these 2 points in here, I think this is going to be negative root 2, and this one's going to be positive root 2. And that's where this is occurring. So the question asks us, find the points. So let's go get those points. So we need to just go find y when x equals 0 for our first one. All right, so let's start listing them out. For x equals 0, that's for our first. So if we plug that in, if I was in a class, I would just do this. Just get rid of everything with x's when you plug in 0. There's your answer, positive 3. I slap my hand on the board and cover up everything. That's the way you solve for it. It's just the shit that's hanging out at the end. So 0, 3, there's a solution. But we're going to need to go and take these negative root 2 and positive root 2 and pop them in. But what's nice is, since we looked at the graph, we know they're the same height. So once we solve for one, we're going to get the other. So let's take our function y, and let's go find out what happens when we want to plug in a root 2. Now, again, it doesn't matter whether I pop in negative or positive. You're going to get the same answer because we're raising something to the 4th and we're squaring it. So what is that? The square root of 2 to the 4th. Well, the square root of 2 times the square root of 2 is 2. And if you do it again, that's 2 times 2. That's 4. That's 4 times. And then we have root 2 squared. That's just 2 plus 3. So what's that? 4 minus 8 plus 3. 4 minus 8 is negative 4 plus 3. That's just negative 1. We did it, y'all. We made it. So now we can write down our 2 other solutions, our root 2, our negative root 2, and both those same y values will be negative 1. There we go. So slope of the tangent line equaling 0 or horizontal. Yeah, duder. That's how we do it, and that's how you get your points. So don't lose sight of this stuff. You'll be tested on it. And I put this shit on the final as well. All right, we'll see you.